Okay, for question number 38, it's given that Suraj's father wants to construct a rectangular garden using a brick wall. And this is a brick wall on one side of the garden. So on one side, it's a brick wall and wire fencing for the other three sides. So this is a wire fencing. This is the brick wall. So one side of the garden will have this, let's say this is the garden, rectangular garden. So this would be a brick wall and the other three walls would be the wire fencing. This will have the fencing of the wire. Now he has 200 meters of fencing wire. Based on the above information, answer the following questions. Let X meter denotes the length of one side of the garden perpendicular to the brick wall, and Y meter denotes the length of the side parallel to the brick wall. Determine the relation representing the total length of fencing wire and also write A of X, that is the area of the garden. Okay, so let's draw our picture first. Let's say this is a brick wall. This is a rectangular garden. Let there be a brick wall. So this is a brick wall. Okay. Now what is given to us is that X meter denotes the length of one side of the garden perpendicular to the brick wall. So let me take this. This is the length side perpendicular to the brick wall. Let this be X. Okay. So if this is X, this is also X because this is a rectangular garden. Now Y meter denotes the length of the side parallel to the brick wall. So parallel to the brick wall is this side and its length is Y. Determine the relation representing the total length of fencing wire. The fencing wire is the three sides, 1, 2, and 3. This is the fencing wire. We have to find out the total length of denote the length of the side. Determine the relation representing the total length of fencing wire. Total length of fencing wire. So total length of fencing wire according to the figure is 2x plus y, and total length of the fencing wire, but it's given that the total length of the fencing wire is 200 meters, so this is a relation 2x plus y is equal to 200 meter. This is the total length of the fencing wire, and this is, let's say, part 1's answer. Now we have also to write the area in terms of x. So area in terms of x, we know that the area is given by length into breadth. So area in terms of x, and area is equal to x into y, length into breadth. And now this is x and we can get a y here. So this will give me y. So y is equal to 200 minus 2x, and okay. So I can write here this is 200 minus 2x and I can take 2 common. So this is 2x into 100 minus x. This is the area in terms of x. X into 200 minus x, length into breadth. Okay, now next question. The next part is asked, determine the maximum value of a of x. So for maximum value of a of x, r a of x is equal to this. So let me just open this. This is 200x minus 2x square. Now for maximum value of a dash x should be equal to 0. So this its differentiation would be 200 minus 4x is equal to 0, which gives me negative 4x is equal to negative 200, and x is equal to 50. So that gives me x is equal to 50. Now let's check whether at this value the area is maximum or not. So let's find out the second order derivative. Write down the second order derivative. You are going to use the second order derivative test. So first order derivative was this, and the second order derivative would be negative 4. So that means at x, when x was 50, it's negative 4, which is less than 0. So that means when x is equal to 50, area is, this is maximum. Okay, so determine the maximum value, and we have to find the maximum value of the x. So the maximum value of the x is at 50. So this is 200 into 50 minus 2 into square of 50. So 5 to that is 10,000 minus 50 squared is 2,500. 25 into 2 is 50. So this is 5,000, and this is 5,000 meter square is the maximum value of the area. Okay, now, so this finishes. Okay, all about, that was all asked in this question. And with this, we are done with this set. So do like, share, and subscribe. Thank you for watching.